Hello again. So we have a UVA exercise which called all roads lead where. So we have multiple cities that are connected via each other. So there's links between these cities, and we need to check what is the shortest path between those two cities. So it's a shortest path problem. We need, and all the connections are of positive edges. So there it costs just one. So we need to use the extra. So it's a very easy exercise. However, the manipulation is about strings, so we need to manipulate strings. However, in my solution, we will overcome this and we'll just manipulate integers. So I have here the implementation of priority queue and a graph, so I will not use that. I will directly implement it directly in the main function. So in the main function, we will be using, so we need to read. First we have one number, which is the number of test cases. Then we have two numbers, 7, which is the number of connections, and 3, the queries. And for each query, we need to display just the first character of the connection. So for example, Turin to Pisa, I need to pass by Rome because I have Turin Rome and Rome Pisa. So I just need to display TRP. So what I will do that, and they are telling us in the text, so you can read it. It's a big long, that the first character is capital, and there is no repeated character. So at most you can have 26 character, and so 26 cities. So the graph would be at most 26 and 26. So I will use that. So I will not do any malloc. So I will first read the first line, and then as far as we go, I will add the declaration. So let's call it T. So this is the number of test cases. So as long as we are moving, so we'll write it here, and at the end we'll have backslash 0. So at the end of the while, so if t is equal to 0, I need to print f a backslash n just to make a space between each case and case. So it's by it was asked in the question. So what I will do that. So next we will read two numbers. So scanf %d %d. So the first one is the number of connections. I will call it m, and the second one is the number of queries. So till now we have three integers, int t, m, and n. This is for now. So while reading this, I need to next read the adjacency matrix. So I need an adjacency matrix. So I will declare it as int. So this is I will call it adjacency list, and it will be of most 26 characters, since we have at most 26 characters, capital characters. So however, while reading this, since we will be calculating the shortest path for each test case, so I need to null this matrix. So I need to place zeros in the while loop. So for that, I will need also two variables for the loops. So let's say v and w. So I will use for v equal to 0, v less than 26, v plus plus, and another one for w, and we will do adjacency list of v and w equal to 0. So this is very important to make it done. And then I will read the m edges. So v less than m, v plus plus. So I need to fill the adjacency list. I need to place, so since it's not a non-direct graph, so I need to place one, and I need to place it in both directions. So however, how can I get this one? So I need to read both strings, and I will get the first character, and then I will subtract it from 0. So I need two strings. So char, let's say that the most characters would be equal to 255. I don't think there's cities with more than this number of characters. So we'll do a scanf here, %s, str1, and str2, and I will get the first character. So it's str1 of 0, so it's a character here. I need to transform it into a number, so I'll subtract capital A, because they told us that all the first characters are capital. So str1 of 0, str2 of 0, and the second one is str2, str1. So I'm constructing the adjacency matrix. And then I need to read each of the queries. I need also to read two strings, and I need to do the Dijkstra. So I'll start from T till I do all the graph, and then I will print from P and backwards to T. So let's start. So we have let's say I will use V, so let me declare I, since I will use V and W inside the for loop. So this one is for the number of queries. So for each query I will need to do a BFS. So I'll start by reading both strings, and I will launch BFS. So in order to use BFS I need a queue. So queue, it is small q, and I'll need distance and also a pass. So let's declare it directly. So in distance, again it's 26, and path also is 26. Let's move down. So we need to create a queue. So here I can copy paste the code from any Dijkstra problem, and I need to initialize both path and distance. So for w equal to 0, w less than 26, w plus plus, I will start from distance of w equal to -1, and also I will place the path of w is equal to w just to when I'm displaying these characters and I'm doing a recursive call. So when I reach the element where t is equal to t, so it's the starting point, it means that the path is equal to itself, I will stop printing. So this is for the path, and then I will start the BFS. So I will enqueue the first element. So the enqueuing will be using a priority queue. So I'll add in queue the element str1 of 0 minus a, so the number, and the distance would be equal to 0. I would say that the distance also of this one is equal to 0. And then I will loop over the queue. So as long as we have a front element, so front queue address of v, so we have v, so what I will do is I will dequeue and calculate the distance dequeue, and then for w we'll check all the adjacent vertices, w less than 26, w plus plus. So if the adjacency list of vw is different than 0, so it means there's a vertex, I would calculate the distance. So let's declare a distance here, also variable. So distance would be equal to distance of v plus the adjacency. So this one is equal to 1, so you can add 1 directly, and we will calculate. So if the distance of w is equal to -1, it means it's never been encountered. So I will update its distance and enqueue it in the queue. So distance of w would be equal to this, and I will enqueue in the queue w with the priority equal to distance, and again I will update the path. So w will pass of w, it should pass by v. So else, so if the distance of w is greater, so if the distance of w is greater than this, so it's already, we are now passing by a smaller distance, so it's it's greater than distance, I will update the distance, and here I need to update the priority. So let me go up and get this. So I'll update the priority of the element, and I will keep the same path. So this is inside the while loop. So inside the for, so for each case I am here. So this is for the while, this is for the BFS. I need to print the path. So I'll write a function, since it's a recursive function. So print path, I will give it the array path, so it's capital P, and I will give it the string str2, the first character of str2. So I'll give it a number. So it's str2 minus a, and I need to print f \n at the end. So I will copy paste this. So I need to write this function, which is a recursive function. So void. So it will take an array, and this is, let's call it t. So I need to recursively print. So I need to print pass this one. So the array would stay the same. However, this one will change. So this one will change. So what I will do, what's the stopping condition here? So the stopping condition is that if this array, so this is an array. So if pass of t is different than t, so this is why we have placed here in the past the same element. So recursively, this is the stopping condition. So as long as this we didn't reach the stopping condition, I will do that, and I will launch the print pass from pass t, and then recursively, so I will print f the character c, and here we will have t plus a, since a is a number. And let's check if we have some errors. So yes, distance. So we have trp, mtrpf, and avtg. So this is right. So let me repeat quickly what we have done here. So we have used the Dijkstra, so it's a shortest path algorithm. So we have initialized the adjacency matrix to 0. We have read all the vertices, and we have launched the DFS for each pairs of strings, and we have recursively printed the path, so from the end to the beginning. So it's not a very difficult exercise, or if you already know how to implement Dijkstra. And this is it for this exercise. If you have any questions, do not hesitate to drop me a message and I will answer you back. And again, thanks for watching.